I slightly changed my title because it was too long, but the content is still the same, promise. So I'm going to talk about what's up with script setup. Now, we already heard or saw in the beginning of the conference during the Q&A with Evan that most people use it or heard about it, but I just want to give a bit of perspective about the history, about some intricacies under the hood, just to give you a better fundamental understanding about why it's there, what it does, and so forth. Just about me, my name is Thorsten Lünborg. I'm from Mannheim, here in Germany. Some of you might know me as Linus Borg, as a member of the Vuejs core team. And yeah, this is one of the few good photos of me. I ripped it from the marketing of the Vuejs Amsterdam conference. There's actually still a logo there. I just put a div, a black div, right at the right top to cover it up. But props to them for getting a good photo of me. Yeah, so what are we going to talk about today? First of all, why does script setup exist? What is the reason? Why is there yet another way of doing things? Then I will go a bit deeper and talk about what is going on under the hood, how it's actually implemented. And when I still have time, which is not sure yet, I will be talking about a few improvements that are up ahead. You already heard about reactivity transform, and so I will go a little bit into that and some other aspects. So, but before we can directly go to script setup, I have to address this. So, when we released Vue 3.0, or actually when we released the first alpha and we proposed the composition API, there was a big clash in the community. And so I would be interested in learning who is still preferring options API. This is great. sorry for you guys. This is probably not your talk, but it's actually amazing because like a year back, or probably like 2 years back, this was more or like a 50-50 split. So that's great. And my suspicion is that part of the reason is script setup, which makes working with the composition API much nicer. But why do we have it? Why did we come up with it? Well, we started with the options API. This has been around for forever, basically the same style. Of course, some aspects changed, but it's there since Vue 2, even in parts since Vue 1. And it's approachable. You find a lot of tutorials about it. You kind of have these neat little properties in the options object where you know I have to put my methods here, I have to put my data here. And so it's pretty easy to get going with it. But the cons are that you have these strict places where you have to put things, so you are kind of restricted in coming up with better ways to co-locate stuff that actually belongs together from a business logic perspective. And you only have mix-ins to share actually behavior, which Natalia already told you about. They have some issues. Also, if you have a big component and you have to understand an aspect of it, you often find yourself jumping from data to methods to computers to data to computers to watch to, and it can get frustrating to actually navigate this. And so, in Vue 3, we came up with the composition API, and this is actually the same component, the same little component that does the same thing, but now everything is in this setup function. And what this allows us is to actually co-locate code by feature instead of by type of the thing that it is or that it does. And so we just write everything in the setup function, then we return the things that we need in the template from it, and then we can use it. And so this is the big pro. And the cons is that you need a little bit of discipline to actually structure your code in a way once you start writing it. And of course, it's a new API. You have to pick it up. You have to learn it. There's not that many resources. And you also have this one stylistic aspect or developer experience aspect of you have this big setup function, and actually all of your work, or the majority of your work, is spent in this one big function, and still it's nested 2 levels deep. You have this big return statement that can grow longer and longer the more properties you want to expose to the template. And really, what we want is, right, we need our imports, we need the actual code in the setup function, and we need this return statement, or maybe we don't. Actually, this is probably good enough. I just realized I screwed up the highlighting at the bottom, but that's not that important. So actually, we just want to focus on this. And that is basically what script setup is, right? It's just getting rid of all this boilerplate around the code that we actually care about, and allowing us to just write our imports that we need and just get into the business logic, instead of having all of this nested stuff that we have to navigate. So no indentation problems, no big return statements. It's much more concise, and also because this is now compiler-based, so we have to actually compile the script block into something that the runtime can understand. While we were at it, we could also do things like make the imports that includes normal imports as well as the components available to the template. So no more component registering, no more custom directive registering, no more making a little helper function just so we can use a low-dash helper in the template. It just is available in the template. And the good news is, for those not yet on Vue 3, it's also available in Vue 2.7 if you use the newest tooling, ever since we migrated this whole composition API back to Vue 2 with the Vue 2.7 release. And before we get into how this actually works and we open up the hood, I want to mention one thing, because there's a big inspiration for this, and this inspiration is Svelte by Rich Harris. And so we have to say thanks, man. Thanks for coming up with this, because this was basically the main inspiration for actually coming up with this syntax. You see that Svelte is still a bit more concise in this aspect, but we have some restrictions that we're working with, and we are still very, very happy with the result that we achieved. Now, onto what goes on under the hood. How does it actually work? Is this something that increases my bundle size? Did we have to implement different things in the runtime to make this actually work? No, this is all compiler-based. So the code at runtime is still the same as if you had written it with this big object and the setup function. And so I took up the challenge, and I have more gray hairs than like 2 weeks ago. I tried to integrate the SFC playground into this slide deck, which was a bit adventurous, but it works. I hope you can kind of read it. And so on the right side, on the left side, you see this little component. It doesn't really do much stuff, but it's enough to demonstrate what I want to demonstrate. And on the right side, you see the actual compiler output. And what you can see quite clearly is that here we have a big old normal component with a setup function. And if you look here, we have like our code is here, but our imports are here where they belong, outside of our component. So that is basically the one thing that the compiler does, right? It takes this big blob of code in the script setup block, it hoists all the imports up to the top, and integrates the rest into a setup function. And you may also notice that the render function, which you see below the one message line with the hello Vue.js.de, that's the render function, and it's inlined into the setup function and returned from the setup function. That is something that you also can do today if you write it, and we'll get back to why that's a good thing that we do it right this way. But yeah, this is basically what's happening. But some of you, some smart people in the audience, so all of you, of course, are wondering, what about props? What about emits? What about other options that I have to set? Because when I said the only thing we care about is what is inside the setup function, I was, of course, simplifying, because we still have this, right? We have the props definitions that are outside of the setup function. We have the emits options that are out of the setup function. And then we have this, the actual setup function that is using the props and emit argument to actually make its code work. So the solution to this, as the headline suggests, are compiler hints. And this is one of the things where people might think, oh, it's something new, I have to relearn everything, and that's not the case. Because all they are is two functions that you have to remember, and you pass in the same stuff that you did before. So define props takes the same kind of object that you usually pass to the props option. And it returns the props object that you normally get as the first argument in the setup function. And likewise, you get the emit function as the return value of the define emits function, and it also takes the same options. So whenever I hear people, oh, this is another API, I think it really is not. It is, in fact, getting rid of a few things that are just cumbersome, and then you have to remember 2, 3, 4 new functions that take the same kind of arguments that you use in other places, and that's it. And what you get for it is much more concise code. And so just to demonstrate that there's also not much magic involved here, we can again look in the compiled output, and we can see that this object here is just this one. And the emits options are here, where they belong, and we can then use the emit and the props. A lot of arrows, but I think you get the point, right? And so yeah, this is basically what the compiler does in order to give you these two options that you basically use in any component that you write, or in most of them, for good or worse. Yeah. So there are, of course, some other things that you also want to use from every now and then. Maybe you need to use slots and adders, which are two other properties on the second argument of the setup function. But you usually don't use them that often. You use them in special occasions. And so what we did here is you simply get two composables. So you have these two functions that you can import from the Vue package. These are not compiler hints. They are actual runtime functions that just give you these two objects that you otherwise would get from the second argument of the setup function. And then you can use them as you would normally do. And this is, in fact, of course, like 2 more lines of code compared to the left. But it's like the trade-off because you don't really use them that often. And now we get to a point that I think not everyone is aware, and that I think is very important. Script setup components are closed by default. And what that means is that any state that you define in your setup function is not exposed as an instance property. So any template ref that you use on a component will not give you access to these properties. Now this confuses a lot of people. I often see issues and questions on Discord about this. But the good thing about this is, especially for component authors, for library authors, as well as for big teams, you no longer have this issue of people using internal state, internal methods, stuff that you actually just have in your component so that it works as an external API. Instead, what you do is you explicitly tell Vue that this message ref that we have here, I want to make this available as an instance property. So somebody putting a ref on the component can actually read it in their script. And you use define expose for this. So this is another compiler hint. You just pass the state to this compiler hint that you want to actually expose as an instance property. And this way you can define an actual, like, thought-out API for your instances. And everything else that you define in your script block is private to your script block and to your template. And so you just have to be aware of this. And by the way, the expose feature is not something that is exclusive to script setup. You can also use it with a normal setup function and even with options API. But for backwards compatibility reasons, an options API-based component as well as a setup component using the setup function are open by default, because that's how it has been since 2.0 or 3.0, respecting what APIs we're talking about. But for script setup, we saw the chance to actually change this without introducing a breaking change, because this is a new feature that previously didn't exist. Now, how does this work under the hood? And here we get back to the render function. So here we have an app that has a ref on this child component, and it actually logs it as soon as it receives it. And I hope this works now. OK, my DevTools are a little bit small. And you can see that it is undefined. We don't have a component instance, and the message property on this one is false. Let's get back into this. Now, if we look at the child component, that's because we didn't call define expose. And so what's happening basically is we are returning the whole render function in the setup function. And so any state that is declared in the setup function is never returned to the instance. It's just there in the setup function. It's never, the component itself isn't even aware that this message variable exists. It's just available in the closure of this render function. And to actually expose it, we would have to simply, you would have to call define expose message. And now if we go back to, now we're going to go back to here, we see that it locks the message, properties content, the value, and we also had a little message in this in check also returns true. So now that we decided we actually want to expose it, it's there. What's the time? Still 12 minutes. OK, we might do a little Q&A session. Yeah, but don't ruin my joke. But what about everything else, right? Because there's still other things that we might want to do in our components. So for example, there's one more exotic option that is called inherit adders, which you might want to set to false if you want to inherit the adders stuff that you receive into a nested element and not the root element. But what about little helper functions that you want to move outside of your actual component instance because you don't want to recreate them on every instance? What about constants or other things that you just want to export from your component? Well, the answer is another script block, one without the setup keyword. So you basically have something like this. You have the script setup component. And here you see we are inheriting the adders onto this input. We don't want it on the label. We want it on the input. And so we have to set inherit adders false, which we can do on this little export default object. And this looks suspiciously like a normal Vue component object. And it kind of is, because what's actually happening is that this object is being merged into the one that the compiler creates, right? So we take this one, this object here, and we merge it into the options object that the compiler created. And I've seen many people, and we have to really quickly, I think, fix this in the documentation and have a big red warning. Try and use data and methods and compute it up there. I even saw I saw someone who basically wrote in the upper script block the whole options API component, and just tried to just use the script setup block to import the components, because then they don't have to register them. Yeah. So I thought that it was creative, but this is not what was intended. Like this is an escape hatch. This up here is an escape hatch, right? This is not what you should be using to write your component. That's what the script setup block is for. But what you can do is you can export const max messages or something is 10, whatever. You can write small helper functions. And everything that you write in this script block is also part of the outer scope. And so it is available in your template. So we could go here and go max messages. and we would say now we have 10. So this is basically the escape hatch for any time that you have stuff that doesn't really belong in the setup function. You can put it in the second script block, but that is actually pretty rare. And so this is another of those cases where it's an edge case, usually. And so when you need it, it's now a little bit more cumbersome. But for the 80% stuff that you have to do, that is more than enough. Yes. So, and with that, we close the hood again a bit, but we may open it up in a second. And we talk about improvements up ahead. And those are two. So for one, we have type-based props and events, which means you can use your TypeScript types to actually define your props and your events instead of having this runtime object. And we have the reactivity transform. For the first feature, this is how it works. So we just learned you can use the define props compiler hint to actually just pass this props object that you already know from the options API, from the normal composition API, and it will just be moved into the props option in the generated code. But what you can also do instead, when you use TypeScript, is you pass a generic argument with an interface that defines the type of the prop, and you can also see like the subtitle here is an optional property, and thus it will be optional. The title will be required true in the compiled output. But there's something that you can also like move it out of the generic, but that is as much flexibility as you get right now, because even though it's already available in Vue 3, the functionality is still limited. Because you have to actually define an interface that is statically analyzable for a compiler to actually make this work. So you can't use a props interface that is generic, which would be great because we all would like to have generic components, and I think that is something that we should be working on or will be working on. But it doesn't work right now, and you also can't import this props interface from another file, because that will mean that we have to read files from the file system, and maybe this file imports it from another file, and then this other file, this props interface is wrapped in an omit, and now we actually have to analyze types to get them at runtime or at build time to actually get the type information, and instead of just statically analyzing the syntax tree. And so, long story short, to me personally, this is cool, but it's not something that I would rely on too much in most of my production code as of now. But better support for this is planned. But as I explained, it's a bit challenging from a technical standpoint. So it might still be a bit of time before we can extend this support for this. So just a quick look. So opening up the hood again, what is actually happening here? And it's pretty easy to see. We just have, here we have this. As we saw, we have this props definition object, and we get this. And if we now instead want to use types for this, we can, of course. We could. We can simply more or less do this, all right? And now this might not seem impressive. Did I make a mistake? Right, thanks. That makes sense. So that might not seem that impressive, but the great thing is that we can now we also have both of these required true. So we actually saved a few keystrokes. There's also some way of creating default values for that, which is a little more verbose, but is more improvable with the reactivity transform. But unfortunately, I don't have that prepared. How long is it? 3-4 minutes, okay. But What we can show also is the reactivity transform itself. So one thing that you might have noticed when you saw the comparison to the Svelte example is that they don't have the concept of a ref. They just use a let variable. We have refs, but we could at least get rid of the import. And that would be all that we have to do is, if you activate this feature in your compiler, you can just add a $ in front of these, get rid of this import, and also make this a let variable. And now, there's no more .value. There's no more imports of these composition API, core APIs. It just works like that. But this is what Evan basically was talking about when he mentioned that we are still hesitant to just put it out there, because I, for example, have been telling people, whenever you want to use a let variable and want it to be reactive, you have to use a ref instead and make it a const, because you can't reassign it. And now we're just turning this on its head and say, hey, you can actually have a let variable and reassign it, and it works. And so this is one of the points where we say, hey, this is cool. And if you would have come up with this right from the start, this would have been even cooler. But now we have to really think hard about how would we introduce this to the wider audience without confusing people even more, because they switch code bases and all of a sudden people are reassigning let variables left and right, and it works. Why does it work? They learned it doesn't work. So we have to really be careful about how we approach this. But it is something that you can play with, and it's something that shows the potential of using a compiler to actually make the developer's life easier, and making the way of writing your code a little bit more succinct, a little bit more concise, and a little bit nicer, basically, yes. And so with this, I come to my last slide, which is just summarizing what I was talking about, basically. So the first point that I really want to stress again is, so script setup is not a third API. It's not options API, composition API, script setup. Script setup is just a more ergonomic way of using the composition API, which had its cumbersome moments. It's using the same runtime APIs under the hood after it's being compiled, so it doesn't introduce more code into the runtime that you use in your browser. It doesn't cost you anything in terms of byte size of your package or of your bundle. And it even performs a little bit better, which is something that I actually forgot to mention. It's not a huge performance increase, but it's actually good that we are inlining the render function into the setup function, because now we have all of the state directly in the closure of the render function. We don't have to actually access it through the component proxy, which has to look up, oh, this property from the template, is it in data? No. Is it in computed? No. Is it in setup state? Yes. All of this lookup is gone because we reduce the state exposed to the template to any variable directly in the closure of the function. And so this saves a few cycles during re-rendering. And like we saw with these further improvements on the types as props APIs and the reactivity transform, there are further compiler-based optimizations that are possible, but Evan also mentioned that we don't want to push this too far, and we instead probably will look more into the direction of the Vapor stuff that will improve the runtime performance of the actual Virtual DOM implementation that we have now. And so yeah, that's what I have for today. This slide was done with SlideF, which is an amazing library to build your presentations with Vue. Check it out if you haven't done so. This is my Twitter, this is my GitHub, and thank you.